Hey, I'm Scott Griffin, and recently I had the opportunity to mentor some software engineering students, and it's given me the opportunity to relive some of my biggest aha moments, those moments where I went from not understanding something to hearing the right word or phrase, and now all of a sudden I understand it. And while that's fresh in my mind, I thought I'd make a few videos highlighting some of those things that really unlock these core concepts for me. The first one I want to take a look at is referencing and what we mean when we talk about a reference in programming. So the first time this clicked for me was when I was looking at a piece of code like this where we're building a hash map. And I remember looking at a line like this and just thinking, I'm never going to understand what this means. This is too complex. And the instructor came in and highlighted just this little piece right here and asked, what is this? And after kind of missing his point, he informed us this is a reference to whatever the value is in that hash map. In this case, it's an integer. And because we have a reference to that integer, we can now operate on it as if we have the integer itself. So that's why we are able to say word map get key plus 1. We are incrementing whatever is here as if this returned 12 and now we are adding 1 to that. So this conversation really sparked an understanding for me of how important the idea of a reference is in programming. And so I want to help formalize that and kind of show what's happening behind the scenes. We're going to take a look at memory and how memory allocation works in relationship to primitives and object type variables. And then we're going to see all the different ways this plays out. So when I first started programming, one of my first questions was, when I create data, where is that stored? The answer I got was, it's in memory. What does that mean? Memory refers to RAM or random access memory, and it's the memory we use temporarily while our program is running. It looks something like this, and you can decide which ones of these refers to the computer style of RAM. But essentially, this is a physical chip, and these chips have billions of transistors on them that can either hold an electrical charge or not hold an electrical charge. And so you may be familiar that when we think of digital, it's binary made up of zeros and ones. Well, zeros are the transistors that are not holding a charge, and ones are the transistors that are. So when we create data, we convert that to binary, zeros and ones, and that is stored physically on this RAM. And then we access that data using the address of those transistors. So our RAM is split into two main sections. We have the stack and the heap. The stack is what we as programmers interact with, and the heap is where the data for objects is stored. So if I create a new object, and you can see on the left I have a person Pojo, which just takes in a name. Here I've allocated memory on the heap for my person object. So that's something like this. So here's my person object, and that's probably an oversimplification, but there's one thing that I want to point out is I cannot currently use this person object. Like I can't print out this person's name. I don't have access to this person. That's because, again, I don't have direct access to the heap. The way we use our objects in the heaps is we need a reference to them. So what we mean by that is we can store this in a reference variable. So I'm going to make a new variable called person P1, and I'm going to assign this person to it. So that is like saying on the stack, I'm creating a person variable. The variable is of type person. And let me figure out real fast what the value of this is. So what I'm going to do is print out P1, run that, and we can see we have reference person at, and this is a hexadecimal representation of our memory location. So this is saying that this value equals that, and this object's address in memory is the same. And so what we're doing is we are creating a pointer. The value of this reference variable is a memory address that points at the object at this memory address, which is this. So that's what we mean when we say we have a reference to something. Now let's check out what happens if I make another person variable. So person P2, currently I'm declaring my reference variable. So let's go ahead and name these. This is P1, this is P2. I don't know this yet, but we will soon. And we can say equals new person Kayla. And let's go ahead and print that person out. And here's our first person, and here's the second person. This is the memory location of our second person. And the address is that. So now we have a reference variable whose value is the address and points to this object in the heap. And because it's in the stack, I can use that. Now let's see what happens when I reassign the value of one of these reference variables. So if I say p2 equals p1, what that is doing is passing the value of p1 to p2. Now this is pointing at a different memory address. So now let's go ahead and print out p2, and we will see that the address is the same as p1. 1EB ends with 46, 1EB ends with 46. So now if I were to do something like, let's reassign, let's say p1 set name, and I'm going to set this to Jamie. Now if I print out p2.getName, what do we expect to happen? We print out Jamie. Even though I reassigned the name of p1, the name of p2 was reassigned to Jamie. Why? Because we went to p1, we said go to that object and run the setName method. We reassigned it to Jamie. But of course, we know that p2 is pointing at the same object. So now, viewing it like this, it's obvious why p2 was also renamed. Interestingly, this other person object no longer has a reference to it, so the Java garbage collector deletes it. We no longer have access to it, we can't use it anymore, so there's no reason to keep it around and take up memory. One important thing to note when thinking about reference variables is there's a difference between reassigning a variable and reassigning a value within the object that a variable is pointing to. That was a confusing sentence, so let me show you. So if I say p1 equals new person object, and we'll make this Wells, and then let's print out p2.getName again, what do we expect to happen here? We're still printing out Jamie, right? p2's name didn't change even though I reassigned p1 to a person whose name is now Wells. That's different than when I used the p1 setName method and renamed it Jamie. Well, what's happening on this side of our demonstration is when we said new person, we are creating a new person object on the heap. So this is Wells. I do not know this memory location, but it is some sort of address. And I assigned p1 to equal that person. So whatever this memory address is now the value of this p1 variable. So this is now pointing at this. Now if I say p1.setName to Kayla, this has no impact on p2 because we just went to p1, go to that object, set the name to Kayla, and p2 is unaffected because it's pointing at a different object entirely. Now, I want to take a second to differentiate how primitives work in Java and how they are passed by value instead of passed by reference. So primitives live entirely on the stack. So if I were to say int x equals 0, and this is a primitive variable, we can tell because int is lowercase, that is one clue. We are creating a variable x whose value is 0. The value is directly stored on the stack rather than pointing to another object. And instead of a reference variable, we have a primitive variable. So let's go ahead and create a second variable, int y equals 1. And let's change the colors of these just so it's obvious they are a different type of variable. So what happens when I say y equals x? I'm reassigning y, the value of y, to the value of x. So let's go ahead and grab the value of x and assign it to y. Now the important distinction is if I were to reassign x to a different value and print out y, what do we expect to happen? Well, we will see that y is still 0. That's because we reassigned x. However, we have no relationship between these two variables. This just took the value of x at the time of this code, and that was the end of their relationship. So whatever we do to x down the road has no impact on y whatsoever. And that is in contrast to how these reference variables work, where changing one impacts the other because they are referencing the same object. Now, we just spent a while talking about reference variables. However, that's not the only way we can have a reference to an object. We don't need a variable necessarily. In the beginning of this video, I showed a map.get example that returned a reference to an integer. So let me show you a few other ways references can be accessed without the use of a variable. So I cleaned up a little bit here, and I'm just going to make a new method real fast. This is going to be called makeMessage, and it will return a string. And this will take in a string called name. And let's call this other name to differentiate between this instance's name. So this is going to return hello, other name. My name is this.name. Okay, so my makeMessage method returns a string. So if I were to say p1 makeMessage and pass in, it needs a string argument. Let's pass in Wells. I can store this in a string variable and then print that out. Let's run that real fast. Hello, Wells. My name is Scott. But because this is returning a string variable, which a string is an object, I can actually look at this as a reference to that new string that I'm creating. And because it's a string or a reference to a string, I can pass this directly into my system out print line message. Just like that. So I'm gonna get rid of this line, run that, and that works exactly the same. Let's take this a step further. I don't need to pass in a name directly. I might want to pass in p2's.getName. Let's go ahead and run that. Hello, Kayla, because p2getName returns a string. It returns a reference to a string object. And because, again, this is a string, I can operate on it like it's a string. So I could say to uppercase, because strings have a method called to uppercase that take that string, return a new string that is all uppercase letters, and I can run that. Hello, Kayla, my name is Scott. So the important thing to note here is that we may have a method that returns a reference to an object, and we can use that reference in the same way that we would a reference variable without having to store it in a variable. Now, if we want to use it more than once, it's probably a good idea to store it in a reference variable. The point here is that a reference is a reference. Let's quickly take a look at some collections and see how this plays out. So let's go ahead and make a new list of person objects, and we'll just call it person list. And my concrete implementation of that list interface will be an array list. And I'm going to go ahead and add P1 to it and P2. So that's going to be the person object that has the name Scott and the person object that has the name Kayla. And in fact, we can instantiate a new person object in line. We don't have to have a reference variable for it. In fact, if you are pulling data out of a database, you're not going to create a bunch of individual variables for each one. You're just going to store each object in a collection. So that's similar to how we don't have an individual variable pointing to this. We just have the variable referenced from the collection itself. And working off that idea that a method can return a reference, check it out. If we were to say personList.get, let's get 2, which is going to be the person at index 2, which is Jamie, we now have a reference to that person. What can we do with that? Anything we could do with a person type variable. Like we could say set name. Let's make it Wells. And then we can go ahead and print out person2.get.getName. Let's go ahead and run that. And we're printing out Wells, not well, Wells. Or we can say personList.get0. I can run a makeMessage method on that. And let's pass in personList.get index1 person. So here we have another reference to a person. And we can see that this is telling me I need a string because my makeMessage method requires a string argument. And this is supposed to be a name. So let me go ahead and write get name. So this whole thing is returning a string. Now, I'm not doing anything with that string, right? I either have to use it or store it in a variable. So we can store it in message like this and print out message. Run that. Hello, Kayla. My name is Scott. And of course, because this is a string, I could run string methods on it, send this whole message to uppercase. There we go. But I don't have to store this in a variable. I'm returning a string, so I have a reference to that string. So I can cut out this whole thing, paste it in here, get rid of this reference variable, and run that. It's the same thing. So a reference is a reference, and it doesn't really matter how we get it. And if you're at all finding this confusing, Think about taking out any piece of this and storing it in its own variable. Like you can always deconstruct this. This person list get one. What if we took that out and stored it in its own reference variable? This is going to be person. Okay, and then we can put that reference variable in its place. So that's a little bit easier to see what's going on. And in fact, let's go ahead and string new person's name equals new person dot get name, right? So that's this method right here. I'm storing that in a variable, and I could pass that new person's name into this argument of the make message method. Now, of course, we want to consider readability and efficiency, but the main takeaway is that a reference to an object is a reference to that object. It doesn't matter if we stored it in a reference variable, or accessing it through some kind of collection, or if it's returned by a method. Once we have that reference, we can operate on that object. Gaining this new perspective of how references work really helped me clarify some other places that I found confusing. For example, encapsulation, when we use the final keyword so that we can't reassign a variable. It was very confusing to me that you could still go to that object and say reset a name or reset some other value within that object, even though this is final. But now I understand that final just means I can't reassign this to a new object. The variable assignment is final, and that has no impact on the object that it is referencing. In polymorphism, we often have a reference variable that is a different type than the object that it is referencing. So for instance, we have here on the left, our reference variable is a list interface, but the object it's referencing is an array list. So those are actually two different types. This is just a concrete implementation of this interface. So again, the reference variable is of type list. The object it's referencing is an array list. And this is of course possible when our object is either implementing an interface or is a subclass of the reference variable type. I hope this was helpful. I know for me, once I started to see these references and understand how they worked a little bit better under the hood, a lot of the other confusing concepts kind of fell into place and everything sort of clicked. So if you found this helpful, let me know. If I said anything that was incorrect, please let me know. I'm still very new at this and still learning, so I will take any feedback you have. Thank you very much.